Dundigal. Myself V. Bhavani from Civil Department. I am working as Assistant Professor in in Institute of Aeronautical Engineering. Today I am going to give the lecture on building materials planning and construction. And here from this building materials planning and construction, what are the course objectives we have to learn? Means students will have to learn that the basics of material science and behavior of various building materials used for the construction process. In construction process, we are going to use different types of materials like cement, bricks, aggregates, etc. And for the completion of this, after the completion of these building materials, we have to learn about cement, aggregates, bricks, and etc. Materials. Okay. And next one is the construction materials required for the assigned work. Means where we are in the construction process, for each construction of the building, we have different types of materials that are going to be used for the construction. Means for your assigned work, what are the construction materials we are going to use? We have to learn in this one. And next one is procedure knowledge of the simple testing methods of cement, lime, and concrete, etc. And here we are having different types of proportions for each and every material, that is cement, lime, and concrete. And in concrete also we are going to mix different types of materials, that is cement, fine aggregate, coarse aggregate, and chemical admixtures, and also we are going to use some of the mineral admixtures also. And by using this overall admixtures, chemical admixtures, mineral admixtures, we are going to increase the strength of the concrete. Where if we are going to construct any type of building, in that one we are going to ensure the strength of the building. That's why we are going to use different types of admixtures in the concrete. Okay, and last one is requirements and different types of states. And in every building, we are having different types of states, like open states, next overall dog-legged states. We are having different types of states, and all we are going to study in this subject, that is building materials planning and construction. And next we are going to firstly we are going to study about the module 1, that is stones, bricks, and aggregates. And in the stones, bricks, and aggregates, we are going to learn in detail of stones, bricks, and aggregates. In stones or rocks will be same only, but rocks nothing but it is a mass. It is having a very big stones, nothing but those are very small, but rocks nothing but it is a very like big boulders like that. And next bricks we are having different types, proportions of bricks. And next one is aggregates. We are having two types of aggregates, that is fine aggregate, coarse aggregate. We are going to learn about the fine aggregate and coarse aggregate. And here we are going to learn about the tests that are used for the quality of these aggregates. For the quality of these aggregates, we are having different types of tests. And in this module, we are going to study each and everything of this aggregate. And going to our course outcome, means after completion of this module 1, that is stones, bricks, and aggregates, student have to be learn about this overall building materials. Means students must have to recognize appropriate building materials that are used in the civil engineering applications for obtaining better performance of the structures. And after completion of this one, they have to learn about the different types of building materials like stones, aggregates, bricks, etc. And what are the best performance they are going to obtain for the structures that we are going to construct. And okay, coming to our module 1, that is stones, bricks, and aggregates. Here I am going to introduce about rock and stone. Means what is the difference between rock and stone. And here you can see the definitions. Rock nothing but what? It is a large concreted mass of earthy or mineral matter or broken pieces of such a mass. Means these rocks are formed When means we can say that because of the natural occurrences, natural disasters, nothing but after the eruption of these volcanoes also, these rocks are going to be formed. And here rock nothing but it is a large concreted mass material, and this rock is having very different types of minerals in this one. And what is meant by stone is it is a quarried or smaller pieces of a rock. Means rock is nothing but it is a very big structure. Not a structure, it is a very big earthy material. Earthy material. And stone is it is the smaller pieces of quarried or smaller pieces of rock for a specified function, such as building blocks. For the building blocks, we are going to use these stones. Means we are not going to use these rocks because these are having very big earthy material. It is a very big earthy material. Directly, we are not going to use this rock for the construction process. After taking this rock, we are going to break that rock in different pieces. After breaking that rock into different pieces only, that naming it is called as the stone. That stone we are going to use for the construction process. Means every construction we are going to use different types of stones. Means it can stones nothing but those are number of aggregates will be there. In aggregates it will be irregular, angular, next rounded. These are all the different types of aggregates we are going to use for the construction process, for the construction of buildings. And next, here, what are the different types of rocks? Means what is the classification of these rocks? Firstly, going to the classification of rocks. In this classification, we are having three types of classification. In this one, first one is geological classification. Geological classification. And in this geological classification, we are having different types. Nothing but sedimentary rocks, igneous rocks. Next one is metamorphic rocks. Okay. And next one is physical classification. And in this classification also, we are again have three different types of classification. And last one is chemical classification. And in this chemical classification also, we are having three different types of classification that are siliceous, calcareous, argillaceous. And each and every classification of this geological, physical, and last one is chemical classification. Each and every classification we are going to learn detail in this class. Okay. Next, going to this geological classification. Okay. Here in this geological classification, we have three different types of classification. In this one, first one will be sedimentary rocks. Next one is igneous rocks, and last one is metamorphic rocks. In this slide only you can observe the different types of rocks for this sedimentary, metamorphic, and also igneous rocks. And these rocks we are going to we are having these rocks where these can be used for the different types of construction purpose, or for the flooring purpose also we can use these rocks. Okay. Firstly, we can learn these sedimentary rocks, igneous and metamorphic rocks. Going to this sedimentary rock. Okay. There you can see these sedimentary rocks. These are formed by the deposition of sediments that are obtained by the weathering of pre-existing rocks, and these sediments are transported by various agents like water, wind, frost, gravity, etc. And means when this weathering takes place, weathering nothing but it is a natural cause. When this natural cause occurring on the pre-existing rocks, sediment will be deposited, and these sediments will be transported by the water, wind, gravity, frost, etc. And after these transported sediments from these layered structures, these give rise to the sedimentary deposits. These sedimentary rocks will be overall, these are formed by the deposition of sediments that are obtained by the weathering of pre-existing rocks. Okay, on pre-existing rocks only, when this weathering process occur, means it is weathering nothing but it is a natural cause only, means disruption of this earthy matter. Okay. On this pre-existing rock, weathering process will be occur. At that time only, sediments will get deposited on the earthing material, and at that time these sedimentary rocks will get formed. For example, sandstone, limestone, lignite, these are all the best examples of sedimentary rock. There you can see the pictures of this sandstone, limestone, lignite, etc. Okay. Nextly, we can go for igneous rocks, and these igneous rocks are formed from the solidification of magma below the earth surface. Means when this volcanoes eruption will be there, at that time solidification of this magma material will be there, no? Magma material that will flow below the earth surface, and at that time these igneous rocks will get formed. Okay, and when this magma is unable to erupt through the earth surface during its upside journey, it is held below the earth surface, and it is unable to descend also. That's why these igneous rocks will get formed below the earth surface only. And in this earth surface, after cooling of this magma means it will be very hot. Means from this volcano only, this magma material will be flows underneath the earth surface. After the cooling of this magma, these igneous rocks will get solidifies. Means like solid material, these igneous rocks will get formed. At that time, these igneous rocks can be easily taken, and these igneous rocks can be used for the construction purpose. It can be used for the construction process also. And here we are having again three types of rocks. In this igneous rocks also, we are having three types. First one will be when this magma hardens at a significant depth. Means from the significant depth from the earth surface, these rocks possesses coarsely grained materials like coarsely crystalline structure. Means these material very coarsely grained crystalline structure will be like some that structure will be somewhat bigger than bigger, and this one is called as plutonic rocks. When this magma hardens at a significant depth, and exact depth we cannot know, it is significant depth from the earth surface, these rocks possesses coarsely crystalline structures, and that type of rocks are called as plutonic rocks. Best example of that one is granite. We are having different types, and just I kept only one example here for the understanding purpose, and there you can see the example, that is granite. Okay, and next one is hyperbasal rocks. And what is meant by these hyperbasal rocks means when this magma hardens at a very shallow depth from the earth surface, then finely grained crystalline structure will get formed. At a very shallow depth from the earth surface, these finely grained structure will get formed. Means finely grained nothing but it will be not bigger than plutonic rocks. Finely grained means size will be very small when compared with this plutonic rocks, and that type of rocks are called as hyperbasal rocks. Okay, it will be the depth of this magma hardens will be very shallow in depth from the earth surface, and that type of rocks are called as hyperbasal rocks. Best example of that one is dolerite. And next one is when this solidification of the rock that occurs near the earth surface, means very nearer to the earth surface, these solidification of the rock occurs, and that type of rock is called as volcanic rock. And mainly these rocks will obtain, these possesses very extremely finely grained structure, and size of these rocks are very extremely fine grained. Means size of this one when compared with hyperbasal and also plutonic rocks, these volcanic rocks size will possesses very extremely fine grained structure. And best example of this structure will be basalt. Basalt is the best example of this volcanic rocks. Okay. Next one is metamorphic rocks, and these metamorphic rocks These are formed by the metamorphism process. Okay. And this metamorphism process, what is meant by this metamorphism process means it is the changing of the characteristics of the pre-existing rocks under the influence of heat and pressure. And when this heat and pressure that will applied on the pre-existing rocks, then this metamorphism process is occurs, and it is nothing but the changing of the pre-existing rock characteristics. Okay, means characteristics nothing but what it may be color, and it may be shape of that structure and texture of that structure. These are the characteristics of this rock, means shape and texture, color of that one will get, of that pre-existing rock characteristics will get changed. When means when it will be exposed to heat and pressure. Heat and pressure applied on this pre-existing rocks, then overall characteristics of these rocks will get changed. That process we can call it as metamorphism process. And these pre-existing rocks, it may be sedimentary or igneous rocks. Okay, in this metamorphic rocks means these overall rocks will be sedimentary or igneous will be there, and on this sedimentary and igneous rocks only this metamorphism process will get occurred under the influence of heat and pressure. When this heat and pressure will be applied on this pre-existing rock only, those characteristics, that pre-existing rock characteristics will get changed, and at that time metamorphic rocks will get formed. Okay, and example of this metamorphic rocks are slate, schist, marble, soapstone, and etc. These are the example of metamorphic rocks, and below you can see the picture of gneiss stone. Okay, and next classification. Till now we learned about the geological classification, and in this geological classification again we have studied three types. That one is igneous rocks, sedimentary rocks, and last one is metamorphic rocks. And these three rocks we have these three are the classification of geological classification. And in the classification of rocks, second one is physical classification, and in this physical classification those are classified physically. Okay, physically again in this physical classification also we have three types. First one is stratified rocks, unstratified rocks, and last one is foliated rocks. And these three rocks characteristics and what are these stratified rocks we are going to know. And next, and in these stratified rocks, these are consist of different layers in its structure. Below you can this figure of these stratified rocks also. There you can see the rock structure, and this rock structure will be layered. It is having different types of layers. Layer by layer these rocks will be there. Okay, and these stratified rocks, it is having different layers in its structure, and these layers are separated by the plane of stratification. And these overall these layers separation will be called as separated by plane of stratification. And these planes, planes of stratification, these planes are also called as cleavage planes, bedding planes. Okay, and these rocks can be easily split up. Okay, easily split up along these bedding planes, because there you can see the picture. In that picture layers by layer structure will be there, and these rocks can be easily split up, easily separated along with this bedding plane only. Okay, and most of these stratified rocks will be sedimentary rocks itself. Okay, why? Because, and in these sedimentary rocks, those are all sedimentary rocks means what? Deposition of the sediments because of this weathering process. And on these sedimentary rocks only these stratified rocks will be explained. Okay, that's why most of the sedimentary rocks will be such as sandstone, limestone, shale, etc. These are all the best examples for stratified rocks. Okay, easily we can just identify these stratified rocks as it is having different layers in these structures. Okay, it is the best known among the rocks. Why? Because it can be easily known. Okay. Next one is unstratified rocks. And these unstratified rocks, these are not layered structure. Okay. These are not layered structure. Layer by layer, the structure will not be there. There you can see the picture also. This overall unstratified rocks will be crystalline or compact granular structure. Okay. And this overall structure is having overall part will be same itself, not layered. Okay. Overall part will be in crystalline nature only. And these possesses similar properties, similar kind of structure throughout its whole body. Means from top to bottom, its overall structure will be, it possesses similar kind of structure. Okay. It will be crystalline or compact granular. Overall part of the structure will be same only. Okay. It possesses similar structure. And most of the unstratified rocks will be, some of them are igneous rocks, and next one is some of them are stratified rocks also. And in this one, best example of this unstratified rocks will be granite, marble, trap, and etc. These are the best examples of this unstratified rocks. Okay. We can easily identify this one as it possesses overall structure will be same only. It possesses similar structure throughout the whole body. Okay. Whether when it compared with a stratified rock, stratified means layer by layer structure will be there. Okay. And in this unstratified rocks, it is not in layered structure. Whole body of this rock will be same itself. Whether it will be crystalline or it will be a compact granular. Okay. Next one is foliated rocks. And here foliated rocks, it possesses, it may be layered or banded structure, which is obtained by the exposure of heat and pressure. And unlike these stratified rocks, these rocks can split up in a certain direction only. Means foliated rocks, nothing but we can say it as the combination of these both stratified and unstratified rocks. We already know that stratified nothing but it is a layered structure, and it can easily split up from the bedding plane itself. And unstratified nothing but overall whole body of this rock will be crystalline and granular, and whole body possesses same properties also. Means same shape also it possesses. Whether and in this foliated rocks case, it possesses both layered and banded structure also. Okay. It possesses layered and banded structure, which is mainly obtained by the exposure of heat and pressure. Okay. And these foliated rocks can be split into certain direction only. And here metamorphism process will get occurred. Okay. Metamorphism process means it is nothing but what means according to the under the pressure of this heat and pressure, overall that basic nature of this rock will get changed. Okay, that is meant by the metamorphic rocks. And metamorphism process will get occurred on this foliated rocks. There you can see picture of this foliated rocks also. Okay, it may be layered or it may be banded structure. Okay. And in this foliated structure, metamorphism process will get occurred. And last one is chemical classification. We completed geological classification we completed. Next is physical classification we completed. And here last one is chemical classification. And in this chemical classification, we have three types. That is argillaceous rocks, calcareous, next one is siliceous rock. Okay. When coming to argillaceous rocks, means in this argillaceous rocks, it is nothing but in the name itself we can easily identify. Nothing but argil means clay. Means these rocks is having the clay material. Okay, and in this clay material, these rocks will possess clay content heavily. Hence, these rocks in which clay content is predominant, That is why it is called as the argillaceous rocks. Nothing but clay rocks we can call it as. Okay. And these rocks are very soft in nature, and with the presence of this water, they can be crumbled easily. Means we can easily see the clay material. When it is combined with water, it is easily crumbled. Okay. Likewise, here also, when this argillaceous rocks, in the presence of water, it get crumbled easily. And in the dry state, these rocks can be easily crushed because of this brittleness. Means these rocks are easily breakable. Okay, in dry state, these argillaceous rocks are very easily breakable. There you can see the laterite structure. Means laterite, it is a one type of argillaceous rock. Best example of this argillaceous rocks are shale, slate, laterite, and etc. Okay, there you can see the picture of this laterite also. We can easily observe the clay content on that rock. Okay, when these rocks are in dry state, it can easily crushed. Okay, because of this nature, because of the nature of brittleness. Okay, and these are very soft in nature, and with the presence of water, these can be easily crumbled also. Okay, argillaceous nothing but clay content will be very heavy in these rocks. Okay, and the next one, calcareous rocks. Calcareous nothing but it in the name itself we can say these having calcium carbonate. The rocks in which calcium carbonate is the major ingredient, that is called as calcareous rocks. Okay, and these rocks are generally hard because these rocks will having calcium content. That's why it is having the nature of this rock is very very hard when compared with this argillaceous rock. And these are generally hard, but their durability is depend on the surrounding constituents. Means surrounding parts of this rock. When these calcareous rocks is it can be easily affected with calcium. Okay, that's why then when it is easily reacted with calcium means their durability will get affected. Okay, that's why this durability will be heavy only, but when it is that depends on the surrounding constituents. Okay, and in this one, main example of this calcareous rocks will be marble, limestone, dolomite. There you can see the picture also. These are the calcium predominant rocks. Okay, from these calcareous rocks, we can easily observe that these rocks cannot be react with calcium because it will directly affect its durability. Okay, because of this effect of this calcium only, their durability will get easily affected. Okay, that's why it depends on the surrounding constituents of this calcareous rocks. Okay, and next one is siliceous rock. And in these siliceous rocks, this rock is having silica content. Okay, very which contains silica in predominant amount. Okay, it is having very heavy amount of silica. Okay, and in previous rocks, that is calcareous rocks, in that calcareous rocks we are having calcium carbonate amount will be very heavy. Okay, and in argillaceous rocks what will be there, clay content is very heavy in nature. Okay, likewise here also in siliceous rocks also these silica content will be very heavy. That's why in the name itself we can see that is nothing but siliceous rock, which is nothing but because of the heavy amount of this silica only, these rocks are called as siliceous rocks. And presence of this large amount of free silica, it makes that rock very harder and also durable, and it also provides strong resistance to the weathering also. When this weathering process occurs, these siliceous rocks will be very strong in nature and easily it can resist strongly. Okay, and these rocks will contain very high amount of silica, and because of this silica itself, these rocks will be harder and also durable when compared with the other calcareous rocks and argillaceous. We already know that argillaceous rocks are easily breakable because of that clay content. And the next calcareous is when it will be depend, that durability of this calcareous rock will be depend upon the surrounding constituents. And that's why these siliceous rocks are very much stronger when compared with this argillaceous and also calcareous rocks. Okay. And when this weathering process occurs means these siliceous rocks will get easily, it provides strong resistance to the weathering process also. Okay. Best example of these siliceous rocks are granite, chert, quartzite, etc. These are the best examples of siliceous rock. Okay. And next one, very important one, properties or requirements of building stones. What are the main properties and main requirements of building stones? If we are going to use the stones for the construction process means we have to know this building properties requirements. Okay. After knowing this building properties only, we can easily identify whether it is good for building construction or it is not good, and whether it can resist the surrounding properties, and whether it that we can know the texture of that stones, whether it will be used for the flooring purpose or for the pavements also. We can easily known by these essential requirements. Okay. By studying these requirements of these building stones, if these requirements will be there in the stones means we can easily go for the construction process. Okay. Each and every property, here you are seeing 18 properties now. These 18 properties we are going to study now, and by studying this we can easily we are going to easily identify the requirements of this building stone. Okay, it may be color, it may be texture, it may be shape, and it may be toughness of that rock. And when it exposed to heat and fire, what will be the effect, and what will be the cost of that stone, everything, and what is the appearance of that stone, we are going to study in these properties of building stones. Okay, these requirements, these 18 requirements we are going to study in this lecture. Next, I'm going to give the short explanation of this properties of building stones. Okay, and the first one is appearance. This appearance is very important in these stones, because it is very important process, because the coloration and ability to receive polish is the fundamental factor. Means after crushing of these rocks, means rocks will be very like boulders, means earthy material. Rock is nothing but very big earthy material. After crushing of this rock, that rock will not be in some specified shape. Means I want my stone in square shape or circular shape. It will not be in that shape. That's why appearance is very important. Whether we have to polish that stone, and we have to give that stone a specific shape also. Okay, that is the very fundamental factor. Okay, that is the very important properties of this building stone also. Appearance. Okay, the coloration and ability to receive polish, that is a fundamental factor of this properties of building stones. And next one, biodeterioration. And this biodeterioration nothing but what means, these plants, means certain timber and creepers, these thrust their roots into the joints of stones. Okay, and these stones, when these those timber rods will root into these stones means, then it is having, that stones will be having chemical and mechanical properties will be there that affect their chemical and mechanical properties. That's why biodeterioration property is also very important one. Okay, when these roots, means plant roots will be thrust into these joints of the stone, no, and at that time stone durability will get affected, and these have every mechanical and chemical the stone will get affected. Okay, that's why this biodeterioration process will also very important property. And next one is color. And this color, why color is very important means, according to the color only we can easily identify the properties. Okay, and these stones with static and attractive color is long lasting. Okay, and it is long lasting if the grains are closely packed, and if that stone is in attractive color also, nowadays after that stone will give some shape. Okay, after taking that stone, we are going to give that stone a specified shape. After giving that specified shape, we are going to use that stone for the decorative purpose of the houses also. Okay, nowadays we are seeing in so many buildings also, with the stones itself they are giving some structure, means in decorative purpose also we are going to use these stones with some attractive color. Okay, and these stones with static and attractive color is long lasting if that one is closely packed. Okay, and these stones with very much iron is responsible for the formation of iron oxide and decomposition of this stone. Means stone having this iron, it will be directly form the iron oxide, and this will cause the decomposition of this stone. That's why each and every stone color is very very important. Okay, when with compared with appearance and also shape, these color is also very very important. Okay, and it is having iron content very heavy, means that will be the, and after that formation of this iron oxide, decomposition of stone will be there. Okay, next one, cost. Cost is very very essential, and if that stone cost is very heavy, means we are going to think about buying that stone. Okay, that's why cost of that stone is also very necessary property. Okay, there you can see cost is an essential term for the choosing in a building. It would not be wrong to say that a single stone is not fulfill all fundamentals of a good constructing stone. If consider one requirement, it affect another one. Means if we are going to take, for example, I'm taking granite stone. Okay, in that one, that granite stone, I can use that granite stone for the flooring purpose. But if I'm going to use that granite stone for the decorative purpose, means it is not at all useful. Granite is useful for flooring purpose, and each and every stone, it is having the good constructing stone only, but all requirements will not be there in one stone. Okay, if I'm going to take one stone, means it is having some requirements, means it is I can use that stone for one purpose only. If I want for another purpose, I have to choose another stone. That's why when we are going to choose these stones also, cost we have to observe. Means cost is a very important property also. Okay, I'm going to buy one stone, means for another purpose I want another stone, and in this case only cost also very heavy for the construction of these buildings. Okay, one stone will not give all requirements for me. Each and every stone is having separate requirements. Okay, and the next one is dressing. Dressing means what? Dressing means converting a stone, converting a irregular shape stone into a desired shape or required shape. Okay, dressing means what? After taking that stones, irregular stones, I am going to give that stone a required shape. That is called as the dressing. Okay, there you can see stone converting into required shape. That is called as the dressing. It must be done in less effort, so the cost of dressing is reduced. Means for this dressing process also cost will be very heavy only. So for in this stone dressing process, less effort will be there, means cost will be very low only. Okay, for this dressing of stones, dressing means if I want my stone in square shape, means I have to give that shape by using the machines. Okay, by using the tools also. By using tools also, nowadays we are using machines, but in the older days they are using only some different tools for the purpose of this dressing. Okay, and by using these tools, we are going to give that stone a desired shape. Okay, if I want my stone in square shape, means I'm going to use that tools and give my stone a square shape. That is called as the dressing. Okay, and the next one is durability, and this durability is very important one. Okay, we have to choose the stones which is successfully resist the destructive outcomes of this natural forces like wind, rain, and heat. Okay, that heat nothing but what? Directly this sun rays will be fall on the stone, means it have to resist that heat also. Okay, sun's heat it have to resist it. Already we can observe that by the sun's heat only so many stones will get break easily. Okay, that's why we have to choose these stones which is successfully resist the destructive outcomes which will be caused by the natural forces like wind, rain, and stone. Okay, and next one is ease in dressing. Ease in dressing means what? That cost of dressing contributes to value of stone masonry to a notable extent. Means when this dressing process will be occurring, that cost of dressing will contribute to the stone masonry. Okay, stone masonry to a notable extent. Means dressing is effortless in stones with lesser strength. Means strength will be less when this dressing is effortless in stones. Okay, and next one is hardness property. Hardness nothing but for each and every stone. This hardness property it plays very important role. Okay, when the stone is used for the ground and pavement nothing but for road purpose. Okay, is used for ground and pavement. The hardness property is very important. Okay, when this for this hardness only, we have to know that stone hardness. For that one only we are going to test that stone by using the Doris testing machine, and below you can see the testing machine also, and this is the Doris testing machine. By using this Doris testing machine we can easily determine the coefficient of hardness. Okay, this coefficient of hardness is to be located through conducting check on general specimen in Doris testing machine. By using this Doris testing method, we can easily know the hardness or coefficient of hardness of that stone. Okay, and next one, resistance to warmness and fire. Means when the stone will affected, it have to be resist the warmness and fire also. The stone need to have a very low volume of expansion due to large prolong in the temperature. Means when this stone will get affected and or it will get exposed to the warmness and fire, means it have to resist. Okay, otherwise that stone is not having any durability. Okay, when this warmness and fire will be there on that when this fire will get affected on the stone, means the stone need to be having very low volume of expansion. Okay, very low volume of expansion due to the large prolonging temperature. Okay, next one is sensitivity to moisture. Sensitivity to moisture nothing but what? Moisture from rain, snow, or different environmental condition that penetrates the wall, main to cracks, rust staining, wood rotting, paint peeling, darkening of masonry. Means after construction of the building, okay, we used some stone, we used overall stones from the construction process. After the building construction, that moisture will get formed. By where this moisture will get formed means like from rain, snow, or different environmental conditions. From different environmental conditions, this moisture will penetrate through the wall. Okay, when the moisture penetrates to the wall, it affect the stone properties. Means it will be affected to the stone, like it get cracks, rust staining, wood rotting will be there, paint peeling will be there, or darkening of masonry will be there. Okay, and the next one is specific gravity. And in this specific gravity, heavy variety of stones are used for the construction of dams, conserving walls, ducts and harbors. For these very important, means very heavy structures, these stones can be used. Okay, and for this construction of dams, stone size will be very large, and for the ducts and harbors also, stones size will be very big. Okay, here we are going to use the different heavy variety of stones for the purpose of construction of dams, walls, ducts and harbors. And that type of stones will have to be specific gravity of right constructing stones will have specific gravity of 2.42 and 2.8. This is the specific gravity of that right constructing stone. Okay, specific gravity is very important also for each and every stone. According to this specific gravity only, afterwards we can use that stone for the construction process. Okay, after doing that specific gravity test for the stones. And the next one is porosity and absorptions. All stones have pores. Pores means what? Small holes. Okay, every stone will be having pores, and that pores will be resulting in absorption of water. Okay, in response of this water, it automatically causes the decomposition. Means if any stone will have pores, and these pores will be result in absorption of water. Okay, absorption of water means after construction of this process, snow, rain will be there. Those are the natural causes. After this rain and snow that fall upon the stone, that stone will absorb this water, and that absorb of this water, it automatically causes the decomposition of this structure. Okay, that's why porosity and absorption is the main factor, main property of this building stone also. And the next one is strength. And for each and every building stone, its strength will be very high. Okay, it should be having very high strength to resist the load coming on that one. Means when this construction process will be there now, at that time on that building stone only we are going to apply the load. Apply the load means construction of these walls, doors, windows and slabs, beams, each and everything will fall upon the stones only, building stone only. That's why it have to be having high strength to resist the load coming on that one. And our main prime concern, therefore it is not of prime concern when it comes to the check the quality of stones. Okay, quality of the stones will be definitely we have to check that one. Okay, when these stones are used for the large structures like dams, ducts, harbors, for the construction of reservoirs, and at that time it becomes necessary to check the compressive strength of that stones. Okay, in normal building constructions it is not necessary. Means when compared with these large structures, in large structures we are going to use stones automatically. At that time we are going to check the compressive strength of the stones. Okay, compressive strength of the stone. And for that building stones we are going to have the compressive strength of 60 to 200 Newton per mm square. That is the good compressive strength which are used for the large structures. Okay, that will be the good compressive strength building stones with the range of 60 to 200 Newton per mm square. Okay, this is the best compressive strength for the building stone. And the next one is texture. Texture means overall fine grained stones with homogeneous distribution. It will look attractive. Okay, fine grained stones. Okay, overall these fine grained stones will having homogeneous distribution overall of that structure. Okay, it will look very attractive also. And they are used for carving purpose. Means for carving nothing but maybe it will be used for decorative purpose, for flooring purpose also. Okay, texture of that one will be um, very good when compared with other stones. Means fine grained stones will be having homogeneous distribution throughout the structure. Okay, and it will look attractive. These can be used for carving purpose also. Such stones that such fine grained stones are generally strong and durable. Okay, which is having homogeneous distribution. These are having very strength. These are having strengthening, and these are having durability also. Okay, and next one is toughness. Okay, in this toughness, building stones are very difficult to sustain the stresses that will be developed due to the vibrations. Nothing but why these vibrations occur means because of the machinery we are going to installed on it. Okay, when this construction purpose will going on, at that time we are going to use the machinery. Okay, we are going to use the machinery for the neat construction of every structure. Okay, at that time when we are going to add the machinery on that building stones means automatically it will be difficult. That building stones will have to bear the difficulty to sustain the stresses that will be developed by this machinery installed on it, and or due to the mass transfer on that one. That's why toughness will be very important property of the building stones. Okay, and because of these vibrations only, it cannot sustain the stresses. Each and every stress it cannot sustain. Okay, next one is weathering. This weathering process, what is meant by this weathering means it is a complex interaction. It is a complex interaction of physical, chemical, biological techniques that can alter the stone in some conventional or particular. This weathering is occurred by the natural cause only. Means some of the deterioration process will be occurring because of the natural process. Okay, at that time it is a complex interaction. It is a complex interaction of physical, chemical, biological techniques. Okay, that can alter the stone. That can alter the stone in some conventional or particular. Okay, and next one is weight and density. And in this weight and density, building stones are automatically those are very heavy in nature. But some denser stones are stronger and weak stones are lightweight. Okay, some of the lightweight stones are used in aquariums also. Okay, in aquariums, these weak stones can be used because those are lightweight in nature. Okay, and building stones are heavy. Okay, according to this weight and density also, we can separate the stones. Okay, and these denser stones are stronger. Okay, each and every stones are having its particular nature. Building stones are heavy. Next, these weak stones are lightweight and denser stones are stronger. Each and every stone we are going to use it in every aspect of the construction. These weak stones are used in aquariums likewise. Okay, and last one in the properties of building stones are seasoning. And these seasoning nothing but what means good stones should be free from the quarry sap. Nothing but quarrying nothing but what? Quarrying nothing but we are going to break the rocks. We are going to deteriorate the rocks for the we are using this rocks for the construction process only. After the breaking of the rock only, we are getting the stones. And if we are going to observe any good stones means that good stone should be free from the quarry sap. And these laterite stone should not be utilized for 6 to 12 months after quarrying. Okay, laterite stone nothing but it is having a clay content. Okay, that's why these laterite stones should not be utilized for 6 to 12 months after quarrying. And these are permitted to get rid of the quarry sap also by the action of nature. Okay, and this procedure of removing quarry sap is called as seasoning. And in this seasoning process, overall this quarry sap will be get removed. Okay, based on the good stones. If it is a good stone, means it should be free from quarry sap. Nothing but laterite stone. This laterite stone is having clay content. Okay, that's why it should not be used for the quarrying process for about the span of 6 to 12 months. Okay, that is nothing but the seasoning. Okay, and that's all about today lecture. Okay, thank you everyone.
Like, share and subscribe. Hit the bell icon for more updates.